Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the concept of problem solving on deadlock in DBMS. Deadlock in DBMS. So, what is meant by deadlock and what are the prevention techniques to avoid deadlock? What are the detection techniques to detect the deadlock situation? And how we can prevent them, how we can avoid them. So these are all we are going to explain in this session. So generally, what is meant by deadlock? So a deadlock is a condition. A deadlock is a condition where two or more transactions are waiting indefinitely for one another to give up blocks. That means a deadlock is a condition where two or more transactions are waiting for execution. So if any transaction is not at all completed, then another transaction is not able to perform. So until and unless the transaction has to be completed, only the second transaction is to be started. So here, deadlock is said to be one of the most feared complications in DBMS, as no task ever gets finished and is in waiting state forever. So if any transaction is to be started, then it is processed, then another transaction has to be wait for the transaction which comes for completion. So until and unless the previous transaction is not completed, then another transactions are to be in waiting state. So the waiting time is more over to take transaction completion. So for example, here in the student table, the transaction T1 holds a lock. Transaction T1 holds a lock on some rows and needs to update some rows in the grade table. So if what I want to do here, I want to update some marks of table 1 or update marks of student. So at that moment the transaction is already in the state of active state. So another transaction is not able to perform. So here transaction T2 holds locks on some rows in the grade table and it needs to update the rows in the student table held by the transaction T1. So the transaction T1 holds the table, those who are updated some rows. Now the T2 is ready to update some more grades. It wants to update in the grade table, but it is already held by T1. So the T2 is not able to perform update operations until and unless the transaction T1 releases. So if T1 releases, then only the transaction T2 performs some update operations. So at that moment, now the main problem arises here. Now transaction T1 is waiting for T2, where transaction T1 is waiting for transaction T2 to release its lock, and similarly the transaction T2 is waiting for T1 to release its lock. So the transaction T1 is requesting for the T2, or else transaction T2 is also requesting for T1. Those two wants to update their grades, those two wants to update their data, but one is already in the active state and the second one is waiting state. So one is already in the active state and the second one is in the waiting state. So here the problems comes. So all activities come to a halt state and remain at all standstill. It will remain in a standstill until the DBMS detects the deadlock and aborts one of the transaction. So previously all the transactions are to be waited. So at that moment one is in the current active state and one is in the current waiting state, and remaining all other activities, all other transactions are in the full waiting state. So taking time to process all the transactions into the area will takes time. So the waiting time is more for to completing the transaction. So that is what main disadvantage of by this condition arises. So here the deadlock situation occurs in this diagram, shows the transaction T1 is with the student, transaction T2 with the grade. So transaction T1 wants to update the grade of the student, but transaction T2 holds this student table. So if I want to update the grade table of the student, the T2 has to release the student table, but it is already held by this transaction T1. So the transaction T1 wants to perform this update operation. The transaction T2 has to release that lock. Similarly, transaction T2 has to update the student table, and transaction T1 has to release that lock. So these two are applied locks on tables to update their data. So to update that data, they need to release their locks. And perform the transaction. So this occur situation is called as what? Deadlock situation. When two or more transactions are executed at the same time and the other transactions are to be in waiting state, at this moment the collision will occur. So this situation is called as what? Deadlock. So this situation arises when two or more transactions are processed together at the same time. So here collision will occur. So that collision leads to deadlock situation. So how we can avoid the deadlock actually? So deadlock is arised because of the transactions are processed more than one at the same time. So how can we avoid that situation actually? So when a database is stuck in a deadlock state, then it is better to avoid the database rather than aborting or restarting the database. So better to avoid the database rather than aborting or restarting the database. And this is a waste of time and resource. So deadlock avoidance mechanism is used to detect any deadlock situation in advance. So deadlock detection is a situation. It finds advanced situation. It finds the advance where the deadlock is occurred actually. So for this, a method like wait for a graph is used for detecting. The deadlock situation. But this method is suitable only for the smaller databases. So wait for graph is one such a deadlock detection mechanism. So it detected advanced mechanism, but it is only for the smaller databases. But for the larger database, deadlock prevention method can be used. And that is the solution only. Deadlock detection. So deadlock detection, how we are going to detect that deadlock situation in advance. So in a database, when a transaction waits indefinitely to obtain a lock, then the DBMS should detect whether the transaction is involved in a deadlock or not. So it checks whether first the transaction is in deadlock situation or not. The log manager maintains a wait for graph mechanism to detect the deadlock cycle in the database. So this is one method to detect the deadlock situation, where all the transactions are to process together and transaction together. So here the wait for graph. So how it is useful to detecting the deadlock detection. So wait for graph. This is the suitable method for deadlock detection. In this method, a graph is created based on the transaction and their lock. So this graph shows that this graph is created based on transactions and their locks. If the created graph has a cycle or closed loop, forms a cycle or closed loop, then there is a deadlock. So it shows that if any cycle will occur or if any closed loop will occur, then it says that there is a deadlock situation occurred. So don't go through that way. So that is what they mentioned. The wait for graph is maintained by the system for every transaction, maintained by a system for every transaction, and which is waiting for some data. It is held by others, which is held by the others, and this system keeps checking the graph if there is any cycle in the graph or not. So the wait for graph for the above scenario is shown in this below. So here, if the transaction is forms like, if the transaction forms like this, if any cycle will occur, if any graph is in cycle or loop, then it shows that there is a chance to occur deadlock situation. So suppose the transaction T1 is 1 and T2 is 1 and T3 is 1 and T4 is 1. So if I go like this, no need to maintain the cycle. If I go like this also, no need to maintain the cycle. So there is no cycle at all in this situation. But when I use this one, then it is automatically created a cycle. So at this moment you can say that it is a deadlock situation occur. It is a deadlock situation occur. So no need to go this way. Again you can see another way. So T1, T2, T3, T4. So at this moment it goes to the next cycle. So again it forms a cycle or group. So no need to go like this. So the graph indicates that what it forms a cycle or loop, then it shows that a deadlock situation occurs. So no need to, better to avoid that cycles or better to avoid that loops. So here the symbol indicates that what. So wait for releasing the lock 1, wait for releasing the lock 2. So transaction T1 holds lock 1 and transaction T2 holds lock 2. So if it releases, then it uses that lock. If it is releases, then it uses this lock. So the holding locks are very important while the transactions are being executed. Holding locks are very important at the time of executing the transactions. So this is the way we can understand the deadlock detection occurs. How it occurs actually, how it detects actually. Deadlock prevention. So deadlock prevention method is suitable for larger databases. So we already said that what deadlock detection is only for smaller database with the help of graph, wait for graph. But for the larger databases, deadlock prevention method is suitable if the resources are allocated in a such way that the deadlock never occurs, then the deadlock can be prevented. If the resources are creating more number of resources for creating more number of resources, more number of resources for more number of resources for what? More number of resources for what? More number of transactions. So creating more number of resources for transaction is sufficient to allocate their logs, allocate their resources. But when you have the condition like less amount of resources and high amount of transactions are, then the deadlock situation always occurs. So here that is what we mentioned here. The database management system analyzes the operations of the transaction, whether they can create a deadlock situation or not. So based upon the number of allocations, we can say that whether there is a deadlock situation occurs or not. If they do, then the DBMS never allowed that the transaction is to be executed. So if we are not creating more than one resources, then deadlock situation always occurs. So then the transactions are never to be executed. So for this, different types of schemes are there. Deadlock prevention schemes are there. So in that, one is what? Wait die scheme. One is what? Wait die scheme. So in this scheme, if a transaction requests for a resource, so here we are talking about what? Transaction and resource. So transaction is requesting for the resource which is already held with a conflicting lock by another transaction. So suppose if transaction T1 wants to use the resource R1, at this moment already R1 is held by the transaction T2, then DBMS simply checks the timestamp of both transactions. So it maintains what? The timestamps. It maintains timestamps for the both transactions. That means the T2 has to complete the transaction within 5 minutes. So it gives 5 minutes time to complete this transaction. After 5 minutes, it should release these resources. Release this resource. Again, the transaction T1 also with the timestamp again with the 5 minutes. So the transaction T1 also holds R1 for 5 minutes. After 5 minutes, it has to release. So it allows the older transaction to wait until the resource is available for execution. So like the way all the transactions are to be in waited state. All the transactions are to be in waited state. For each and every transaction, it should allocate some time. It should allocate some time. So this is what we mentioned here. Let us assume that there are two transactions, Ti and Tj. Ti and Tj, and let Ts of T is a timestamp of any transaction T. Timestamp of any transaction T. That means we are allocating some time, 5 minutes or 10 minutes or 4 minutes or something. We are allocating some time for the particular transaction to complete the task. To complete the task. After the completion of the task, the transaction has to release that resources. Release that resources. So if T2 holds a lock by some other transaction and T1 is requesting for resources held by T2, then the following actions are performed by DBMS. Then the following actions are performed by DBMS. So what are the actions to be taken by the database management system? So it checks if timestamp of transaction T1 or transaction T2 is less than that of timestamp of transaction T1 or T2. If Ti is the older transaction, that means it is an older transaction, and Tj has held some resources at that moment, then Ti is allowed. Ti is allowed to wait until the data item is available for execution. That means if the older transaction is waiting for a resource which is locked by the younger transaction, then the older transaction is allowed to wait for resource until it is available. So that older transaction has to wait for some amount of time because it is already in the state, it is already in the waiting state. So younger transaction is to be executed first, then older transaction is to be waiting later, waiting for long time. And in this condition, it is going to be used for the resources which are held by the transactions. And the second case, if timestamp of Ti or T1 is less than that of timestamp of Tj, if Ti is older transaction and has held some resource, and if Tj has waiting for it, then Tj is killed and restarted later. Tj is killed and restarted later. So with a random delay, but with the same timestamp. So sometimes the wait, there are two mechanisms. One is to be waiting state, or else second one is dying state. One is to be waiting state, or second one is dying state or killing state. So that means older transaction has to be wait for longer time, and younger transactions have to be executed first one. And here the second case, the older transactions are to be used by the resources or to be killed by the younger transactions. So this is what we understand from this deadlock prevention mechanism, wait die scheme. And the second one, wound wait scheme. Wound wait scheme. So in this scheme, if the older transaction requests for resource which is held by the younger transaction, then older transaction forces younger one to kill the transaction and release the resources. Release the resource. So if the older transaction is requesting for a resource which is held by the younger transaction, then older transaction forces younger one to kill the transaction and release the resource. After a minute of delay, the younger transaction is restarted, but with the same timestamp. But with the same timestamp. If the older transaction held a resource which is requested by the younger transaction, then the younger transaction is asked to wait until older release it. So younger transaction has to be waited. It is asked to wait until older releases. So older transaction has to be released for the younger transaction at a certain time of time. Certain time of time. So this is what wound wait scheme. So that is two are deadlock prevention mechanisms. So for this, because of this, what are the failures we will see in the systems. So there are different types of failures are there. So one is the transaction failures, system crashes, disk failures. So to find where the problem has occurred, generally a failure into the following categories. So what are the failure categories? One is transaction failure, second one is system crash, third one is disk failure. So first one is what? Transaction failure. Transaction failure. It occurs when it fails to execute or when it reaches a point from where it cannot go any further. So if a few transactions or process is hurt, then this is called as a transaction failure. So in the middle of the transactions, if it reaches maximum point from where it cannot go any further, then it leads to failure state. So there are different types of failure states. One is what? Logical errors. So reasons for transaction failures could be the logical error is one such way. If your transaction cannot complete due to some code error or any internal error condition, then the logical errors occurs. And syntax errors. It occurs where the DBMS itself terminates an active transaction because the database system is not able to execute. For example, the system aborts an active transaction in case of deadlock or resource unavailability. So, in case of deadlock or the resource or unavailability situation, then the syntax errors are occur. So, because of these two reasons, logical errors or syntax errors, sometimes the transaction may get failure. So, what are those reasons? Some code errors or internal error conditions or nothing but logical errors. And the syntax errors are transaction state errors and which is not able to execute in that state. So that is the syntax errors. System crash. So system failure can occur due to power failure and or other hardware or software failure. Other hardware or software failure. So example, operating system error. So one is example, operating system error. So if any configuration settings are changed, if any operating system services are to be destroyed, at that moment system automatically leads to crash. And a fail stop assumption. In the system crash, non-volatile storage is assumed not to be corrected. Not to be corrupted. And third case, disk failures. Disk failures. So it occurs where hard disk drives or storage drives used to fail frequently, and it is a common problem in the early days of technology evolution. And disk failures occurs due to the information of bad sectors. So disk is nothing but what? A disk contains all the sectors, right? So if the disk is not configured with the sectors properly, then it automatically closer to disk failures. And the disk head crashes also, and unreachability to the disk or any other failures related to the disk completely. So it leads to completely destroy all parts of the disk storage. It completely destroy all parts of the disk storage. So this is the way we can understand the transaction failures because of the deadlock situations or because of the transaction states failures, because of the system crashes and everything. So for this, what is the mechanism? For this, what is the mechanism we are going to recover the data, recover the transactions also. So for that, we can use the log-based recovery, one such a mechanism to recover our data or to recover our transaction. So what is meant by log-based recovery? So the log is a sequence of records. So log is nothing but a sequence of records. So log of each transaction is maintained in some stable storage, so that if any failure occurs at anywhere, then it can be recovered from there only. Or automatically, or it is an active state. If any operation is performed on the database, then it will be recorded in the log. But the process of storing the logs would be done before the actual transaction is applied in the database. So whenever the transaction is to be started, during the transaction and after the transaction also, each and every time how what time transaction is started, what time transaction is moved from one to another state, everything will be recorded and logged. So let us assume there is a transaction to modify the city of a student. City of a student. Take an example. The following logs are written for this transaction. So what type of logs you are written? So now the transaction is started. When the transaction modifies the city from Noida to Bangalore. So I want to modify the city from what? Noida to Bangalore. Then another log you need to write. Another log you need to write. So what we can write the log? So transaction, the name of what? City from Noida to Bangalore. So Noida is the present state and Bangalore is the next state. So when the transaction is finished, then it writes another log to indicate the end of the transaction, that is the transaction commit. We need to mention what? Transaction commit. So to do this all log based recovery, there are two approaches to modify the database. There are two approaches to modify the database. What are the two approaches actually? So one is what? Deferred database modification. Deferred database modification. And the second one is what? Immediate database modification. So deferred database modification technique occurs if the transaction does not modify the database. If the transaction does not modify the database until it has committed. So until it has committed, if the transaction does not modify the database, so that is nothing but what? Deferred database modification. And in this method, all the logs are created and stored in the stable storage. So in this transaction, in this method, all the logs are created and stored in the stable storage. And the database is updated when a transaction commits. Database is updated when a transaction commits. So automatically commits operation, then the database gets modified. And immediate database modification. Second one is what? Immediate database modification. So in this technique, it occurs if database modification occurs while the transaction is still active. So at the time of completion of the transaction, it is going to be modified. Until and unless it is not necessary, it is not required for, it is not bothered about to commit operation. So in this technique, the database is modified. In this technique, the database is modified immediately after every operation. So the database gets modified immediately after every operation. It follows an actual database modification. It follows an actual database modification. When the system is crashed, then the system consults the log to find which transaction need to be undone, and which need to be redone, So what transaction is to be at what time? The transaction is to be in active state, or what transaction time the transaction is to be redone, is to be maintained in this log based recovery. So if the log contains the record what transaction start, transaction commit, and the transaction commit, then the transaction needs to be redone. And in these cases, the transaction is to be redone. If log contains the transaction start but does not contain the record either commit or abort, then the transaction needs to be undone. So at this case, we need to maintain the log-based recovery. So these two are the techniques, the database modifications before the commit operation and after the commit operations, immediately of the transaction. So deferred database modification occurs after the commit operations, and immediate database modification occurs for each and every transaction completed. The database gets modified. So this is about the log-based recovery mechanisms to recover the transactions for a yearly basis. So once again, we revise the topics which we discussed in this session. So in this session, we are going to discuss what is meant by deadlock. So when two or more transactions are requesting for the resources to utilize them, at this moment the resources are not available, then the transactions are to be in collision occur. So at this state, the deadlock situation occurs. We can detect the deadlock where the situation occurs, and we can prevent the deadlock using some methods. So here, deadlock avoidance. So we have a method called wait for a graph to detecting the deadlock detection. And the deadlock prevention, we can have the different types of prevention techniques. One is what? weight die scheme, and the second one is what? Wound weight scheme. So these two are deadlock prevention techniques. So after deadlock occurs, the transaction gets failure. So how many ways the transaction get failures? The failures classification. One is what? Transaction failure, and the second one is what? System crashes. Third one is what? Disk failures. So transaction automatically failures because of the logical errors places or syntax error places. And the system crashes also will based on the operating system configuration settings changes or software failures also. Disk failures, it is completely related to the disk storage problems. So after this, how can we recover the data? How can we recover the transactions actually? So for that, we have a method called log-based recovery to to record each and every transactions of the data. So what transaction is to be started, what time it is started, what time it is in active state, what time it is in committed state, and everything, every record will be noted here. So that is all about to log-based recovery. So in these two techniques, one is deferred database modification, and the second one is immediate database modification. So deferred database modification occurs after the commit operations. Immediate database modification occurs whenever the transaction completed automatically it gets committed. So this is all about to deadlock in DBMS. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.